Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new. All right, let's start with the AI tooling radar. Big news from OpenAI. Rumor has it they're integrating more advanced multimodal capabilities directly into their coding models. What's the read on that?
The whispers suggest deeper integration with visual and perhaps even audio inputs, allowing models to interpret UI designs or voice commands for code generation. If true, this moves beyond text to code, pushing towards a more ambient, context-aware coding experience. The implication is a much richer, albeit more complex, development loop.
So less explicit prompting, more intuitive understanding of intent. That's a significant leap for developer experience, but also potentially a new vector for unexpected behavior if the context isn't perfectly understood.
Precisely. More convenience often means more surface area for misinterpretation or even subtle vulnerabilities introduced by ambiguous multimodal prompts.
Moving on, Anthropic's Claude Code 3.5 has been showing up in some new benchmarks. The claims are impressive, but what's the reality check there?
Performance reports indicate notable improvements, particularly in code comprehension and refactoring tasks. However, the recurring challenge appears to be consistency across highly complex, multi-file projects. While it excels on isolated problems, maintaining coherence over large code bases remains a frontier for all current models, including Claude.
So still a powerful copilot for specific tasks, but not yet ready to manage the entire flight plan on its own.
Exactly. It can be thought of as an expert co-pilot for short, intense legs of the journey, not the captain for transcontinental flights.
And GitHub Copilot itself, any fresh updates?
GitHub recently rolled out enhanced enterprise security features, focusing on IP protection and code attribution within organizational contexts. This includes better tracking of generated code provenance and finer-grained control over what Copilot can suggest based on internal code policies. It's a clear move to address enterprise concerns around intellectual property leakage and compliance.
That sounds like a direct response to the early anxieties businesses had about Copilot's use of public code bases. They're trying to build trust for broader adoption.
Absolutely. It's about making Copilot palatable for highly regulated industries and companies with stringent internal security and IP policies, turning a potential liability into a manageable asset.
Turning to Google, Gemini's code assistance capabilities are reportedly getting tighter integration with their cloud services. What does that mean for developers already in the Google ecosystem?
The strategic play is to make it seamless to develop, deploy, and manage applications within Google Cloud, leveraging Gemini's understanding of their specific APIs and services. For those entrenched in that stack, it promises a significant reduction in friction. For those outside, it highlights the increasing vertical integration of AI coding tools with specific platform ecosystems.
So less about general programming prowess and more about supercharging development within a particular walled garden.
It's a play for ecosystem lock-in, but also a legitimate efficiency boost for those who've chosen that ecosystem. They're deepening the value proposition for their existing users.
Finally, Cursor has been making noise with the new plugin architecture. Any thoughts on its significance?
The move towards a more open plugin architecture for Cursor signals a recognition that no single AI model or set of features will satisfy every developer's needs. It decentralizes innovation, allowing the community to extend its capabilities. This could be a differentiator, fostering a vibrant ecosystem of specialized tools built on top of Cursor's core.
A modular approach, then. Rather than trying to be all things to all people, they're letting the community fill in the gaps. That could lead to some really interesting niche tooling.
It's a smart strategy to scale functionality and adapt to diverse workflows without having to build every feature internally.
Reports indicate GitHub is building what's being called an Agentic immune system, designed to scan servers, specifically MCP servers, for threats from AI coding agents. The phrase agentic immune system itself evokes a biological comparison. It suggests a proactive, self-defending mechanism for code.
That framing is deliberate, drawing a parallel to how biological systems identify and neutralize pathogens. The core idea is that as AI coding agents become more autonomous and capable, they also present a new class of security risks. GitHub, as a central repository and development platform, sees itself in a position to develop a defense mechanism against these emerging threats.
So it's not just about patching vulnerabilities in human-written code, but fundamentally anticipating and preventing AI-generated malicious behavior. That's a significant shift in thinking.
Exactly. It's moving beyond traditional static and dynamic analysis of code to understanding and monitoring the behavior of the agents themselves and the environments they operate in.
Let's delve deeper into this agentic immune system concept. What precisely does that metaphor imply for how GitHub intends to secure these AI coding agents?
The analogy suggests a multi-layered defense. In biology, an immune system has various components: identifying foreign bodies, remembering past threats, and launching targeted responses. For AI agents, this translates to continuous monitoring of their output, their interactions with development environments, and their network activity. The aim is to detect anomalous behavior that could indicate a malicious intent, much like an immune system flags a virus.
So it's not just about scanning the code that's produced, but observing the process of its creation and deployment by an AI. That sounds like a much more active and intrusive form of security.
It is. The traditional security model often focuses on the artifact, the compiled code or application. This agentic immune system extends that focus to the agent itself, treating it as a potential vector or even originator of threats, regardless of whether its output looks overtly malicious at first glance. It's about threat intelligence at the agent level.
Let's discuss the MCP server part of the equation. GitHub is reportedly scanning what it describes as MCP servers. What exactly are these in this context, and why are they a specific focus for this agentic immune system?
While the specific acronym MCP isn't universally standardized, in this context, it refers to multi-cloud platforms or managed container platforms, environments common in modern enterprise infrastructure. They are often complex, interconnected systems where code is deployed, tested, and run across various cloud providers or internal infrastructure. They are attractive targets because compromising an agent operating within such an environment could grant access to vast swaths of an organization's digital assets.
So, it's about the blast radius. A rogue AI agent on a developer's local machine is one thing, but an agent with elevated privileges in a production-like multi-cloud environment could cause catastrophic damage.
Precisely. The stakes are significantly higher. These platforms are where sensitive data resides, where critical business logic executes, and where vulnerabilities can be exploited at scale. GitHub's focus on these servers underscores the recognition that the threat isn't just theoretical. It's an enterprise-level concern that directly impacts operational integrity and data security.
What kind of malicious activities are these AI agents potentially capable of that necessitate such an advanced defense? This goes beyond simple coding errors, correct?
The potential threat vectors are diverse. Firstly, there's malicious code generation. An agent, either compromised or intentionally designed, could inject backdoors, logic bombs, or even ransomware components into a codebase. Secondly, data exfiltration. An agent with access to sensitive data during development could autonomously identify, package, and transmit that data to external unauthorized servers. Thirdly, unauthorized resource access. If an agent is granted broad permissions, it could provision cloud resources, launch compute instances, or manipulate data stores outside of its intended scope, leading to cost overruns or even denial of service attacks.
So it's not just about a bug in the code, but the agent actively trying to do something harmful, like an automated insider threat.
That's a very apt way to put it. It represents a fundamental change in the approach to defending against external human hackers, moving to defending against potentially compromised or malevolent automated entities operating within the development and deployment pipeline. It highlights the potential for autonomous agents to act with a degree of intent, or at least a misaligned objective that traditional security models weren't designed to handle.
How does GitHub's agentic immune system actually work in practice? What mechanisms are in place to detect and mitigate these threats?
The system likely involves several layers. One is behavioral analytics, monitoring how an AI agent interacts with the codebase, development tools, and network. Is it accessing files it shouldn't? Is it making unusual API calls? Another layer is code analysis, not just for vulnerabilities, but for patterns indicative of malicious intent, perhaps using a constantly updated threat intelligence feed. There's also likely runtime monitoring within the MCP environments themselves, observing the agent's deployed outputs and resource consumption for anomalies.
So it's a combination of profiling what normal agent behavior looks like and then flagging anything that deviates significantly, combined with actively scanning for known malicious code patterns. It sounds like a constant game of cat and mouse.
It is, and it's complicated by the probabilistic nature of AI. What might appear anomalous could sometimes just be an unusual but legitimate action. The system needs to be sophisticated enough to differentiate between a novel, beneficial action and a genuine threat, minimizing false positives while maximizing detection rates. It's a challenge of context and intent.
This raises a critical question about the implications for developers and enterprises. If GitHub is actively monitoring and scanning the behavior of AI agents, even on internal servers, what does that mean for developer autonomy, privacy, and control over their own development environments?
That's the crucial tension point. On the one hand, enterprises demand robust security against novel threats. On the other, developers value privacy and unhindered access to their tools. This system implies a degree of surveillance or oversight over agent activities, even in private repositories or internal build pipelines. For developers, it might feel like a loss of direct control or an additional layer of scrutiny. For enterprises, it's a necessary trade-off for mitigating significant risk, shifting some of the security burden to the platform provider.
So, a potential for friction between security needs and developer freedom. Is there a parallel here to how traditional endpoint detection and response systems monitor human user activity on corporate networks?
There are definite parallels. Just as EDR systems monitor user behavior for anomalies that could indicate insider threats or compromised accounts, this agentic immune system monitors AI agent behavior. The key difference is the autonomy of the agent. A compromised human still has a human brain. A compromised AI agent could act with unprecedented speed and scale. This means the stakes for detection and response are even higher, potentially justifying the more intrusive monitoring from an enterprise security perspective.
Looking at the broader landscape, is this agentic immune system a response to a completely new type of threat or an evolution of existing security challenges?
It's arguably both. The concept of an insider threat or malicious code injection isn't new. What's new is the agent of that threat. AI coding agents introduce an entirely new class of autonomous actors into the development pipeline. They can generate code, interact with systems, and potentially make decisions at a speed and scale impossible for a human. This necessitates an immune system that can understand and respond to intelligent, automated adversaries, rather than just passively scanning for known vulnerabilities. It's an active defense against active, intelligent threats.
So the intelligence of the threat demands an intelligent defense.
Exactly. It's an arms race of intelligence, where the defense needs to match or exceed the potential for automated malicious action.
This is certainly a lot to consider as AI agents become more prevalent. For listeners trying to make sense of this, what are the 3 or 4 most important takeaways from this development?
First, the rise of AI coding agents is fundamentally reshaping the threat landscape, moving beyond traditional human-centric vulnerabilities to autonomous, intelligent threats. Second, platforms like GitHub are taking proactive, systemic measures, creating immune systems that monitor agent behavior rather than just code artifacts. Third, enterprises must now consider AI agents as potential security vectors, requiring new policies and oversight. Finally, this introduces a crucial tension between security enforcement and developer autonomy, which organizations will need to navigate carefully.
So, the responsibility for security is expanding to include AI agents, and that's going to require a new mindset from everyone involved.
Indeed, it's a recognition that the tools themselves now need guardians.
That leads to a compelling question for everyone listening. As AI agents become more integrated into critical infrastructure, how much oversight and immune system monitoring is too much? And where is the line drawn between necessary security and stifling innovation or privacy?
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. we cover what matters.
Ship smarter, not harder.